That familiar face in our night sky holds secrets we are only beginning to uncover. You might think we know everything about our moon, but prepare to question what is real. Across its silent surface lie strange features and fleeting phenomena that defy all explanation, known as lunar anomalies. By the end of this journey, you will know 25 of the most baffling lunar mysteries that still leave scientists utterly stumped. We will explore glowing patterns that appear painted onto the rock, and bizarre structures that look anything but natural. What do you believe is waiting for us on the moons scattered across the gray lunar plains are stunning formations that look like ghostly works of art. These are the lunar swirls, and one of the most famous is known as Rayner Gamma. Imagine bright, swirling patterns, almost like cream stirred into coffee, painted directly onto the surface of the moon. But these are not simple stains. They are brilliant, complex designs that seem to float above the landscape, completely ignoring the hills and valleys below them. High-resolution images from orbit reveal their eerie, ethereal beauty, patterns that feel both deliberate and alien. The most baffling part is that we do not know what creates them. They are not made from different rock, and they are not related to any volcanic activity. One leading theory points to comet impacts. The idea is that a comet, a massive ball of ice and dust, might have struck the moon at a shallow angle. The impact could have scoured the surface in a swirling motion, altering the soil's properties to make it more reflective. Another fascinating idea involves the moon's own mysterious and patchy magnetic fields. Perhaps these swirls mark spots where the local magnetic field is strong enough to deflect the constant barrage of solar radiation, preventing the soil from darkening over time and leaving these bright, protected swirls visible. Yet, neither theory fully explains their perfect, artistic shapes. What force could possibly paint such precise and beautiful patterns on a world devoid of air and water? This is just the first whisper from the lunar surface, a hint that the moon's quiet face holds forces we have yet to comprehend. While these ghostly patterns are permanently etched in the moon, other mysteries are far more fleeting. For centuries, sharp-eyed observers have witnessed sudden, inexplicable bursts of light and color dancing across the lunar surface. These events are known as Transient Lunar Phenomena, or TLPS. They are not the gentle glow of Earth's time, but brief, localized flashes, sometimes appearing as brilliant white sparks, or even as patches of deep red. Even the Apollo astronauts joined the ranks of witnesses. The crew of Apollo 11 reported seeing a bright, glowing area near the crater Aristarchus, a region notorious for such activity. These phenomena take many forms. A dark patch might suddenly appear. An area of the surface could glow with an unearthly red hue, or a pinpoint of light might flash for just a second before vanishing back into the eternal black. The greatest challenge for scientists is their unpredictable and transient nature. By the time a telescope is aimed at the location, the event is usually over, leaving nothing but questions. So what could possibly be causing these lunar fireworks? One theory points to outgassing. The idea is that radioactive decay deep within the moon might release pockets of gas, like radon. When this gas escapes into the vacuum of space, it could disturb the fine lunar dust, making the area appear momentarily bright or hazy. Another, more straightforward idea is meteoroid impacts. The moon has no atmosphere to burn up space rocks, so even small ones slam directly into the ground, creating a brief, violent flash of light upon impact. Yet, this does not explain the longer-lasting glows or the strange color changes that have been documented. No single theory seems to account for every single reported event, leaving us with a puzzle that has persisted for hundreds of years. The moon, it seems, is not a dead world, but one that occasionally winks at us, reminding us that its secrets are still very much alive. But beyond fleeting lights and ethereal patterns, some anomalies appear to be permanent structures of impossible scale. Two of the most debated are known simply as the Shard and the Tower. The Shard was first identified in images taken by the Lunar Orbiter program, appearing as an impossibly tall, thin spire rising from the surface. It casts a long, dark shadow, and its geometry suggests a sharp, almost crystalline structure that seems to defy natural erosion. Not far away, another formation called the Tower is even more staggering. Some analyses suggest it could be over 5 miles high, a colossal pillar that, if real, would represent a feat of engineering far beyond human capability. Proponents of ancient lunar civilizations point to these features as the ultimate proof, the ruins of a lost culture that once called the moon home. They argue the precise angles and sheer scale are simply not products of random geological processes. The counter-argument from mainstream science, however, is rooted in a powerful trick of the human mind called pareidolia. This is our brain's innate tendency to find familiar patterns in random shapes, like seeing a face in a cloud or a figure in the flickering shadows of a fire. The lunar surface is an incredibly rugged and stark landscape, a world of extreme contrasts between brilliant sunlight and absolute blackness. A jagged mountain ridge, when lit from a low angle, can cast a complex shadow that looks unnaturally straight and tall. A cluster of large boulders on a crater rim could, from a single orbital camera's perspective, align perfectly to create the illusion of a single massive pillar. What we perceive as a towering shard might just be a small, jagged rock sitting on a closer hill, its shadows stretched to an incredible length by the low sun. While the images are compelling, they remain a powerful testament not to alien architects, but to our own human desire to find order and meaning in the chaotic beauty of the cosmos. These strange spires are not the only formations that challenge our perception. Another set of mysterious structures was captured in a photograph from the Lunar Orbiter 2 mission, an image that has become legendary among anomaly hunters. In a wide, flat area known as the Blair Cuspids, the camera captured a cluster of incredibly tall, slender spikes. They stand in a seemingly perfect geometric arrangement, like a set of dark, ominous needles thrust up from the lunar plane. Their shadows stretch long and sharp across the dust, allowing for rough calculations of their height, with some estimates suggesting they tower as high as a skyscraper. The arrangement is so orderly that it is difficult to dismiss it as a simple random act of nature. Then there is the lunar bridge, a feature that looks exactly as its name implies. In images of the crater Mare Crisium, a stunningly perfect arch appears to span a chasm. Its symmetry is so precise that it evokes the grand stone bridges of our own world, a structure that seems engineered for a purpose, not carved by chaotic forces. Could this be a remnant of some colossal architecture, a viaduct built to cross a lunar ravine? Perhaps the most geometrically intriguing of all is the triangular feature near the crater Eucert, often called the ruins of Eucert. From above, it does not look like a typical crater or hill. Instead, it presents a near-perfect equilateral triangle, and within its boundaries, some observers claim to see a pattern of smaller, equally geometric shapes, like the foundations of a vast, ancient complex. It is a sight that fires the imagination, suggesting the ghost of a city frozen in lunar stone. Yet, geology offers its own compelling narratives for these seemingly artificial wonders. The Blair cuspids, for instance, could be the last remnants of a much harder volcanic rock. Imagine a vast sheet of lava that once covered this region. Over billions of years, the softer material around these tough formations eroded away, worn down by the constant microscopic rain of meteoroid impacts, leaving only these resilient spires standing guard. Their apparent alignment could be a trick of perspective, or simply a fracture pattern in the original bedrock that guided their formation. The magnificent lunar bridge is likely a classic example of a natural arch, a feature we see here on Earth in places like Arches National Park. Such formations are created when softer rock is eroded away from underneath a harder, more resistant cap rock. On the airless moon, this erosion would be performed not by wind or water, but by seismic tremors from nearby impacts, slowly shaking the landscape until a section collapses, leaving a bridge behind. The perfect shape is a temporary snapshot in geological time, destined to eventually collapse under its own weight. As for the ruins of Euchert, the perfect triangle is probably the result of a very specific type of impact. A meteorite striking the surface at a very low, grazing angle can create a distinctly non-circular crater. The resulting shape is often elongated or polygonal, and a triangular form is well within the realm of possibility for such a violent, oblique collision. The smaller internal patterns are almost certainly the work of subsequent, smaller impacts and landslides that have scarred the interior of that initial wound. What we perceive as a planned city grid is just the chaotic beauty of destruction, frozen in time. The true mystery lies not in proving they are artificial, but in understanding how the natural forces of the moon can so perfectly mimic the works of intelligence. Rising from the flat, dark plains of the lunar marea are immense, smooth structures that seem almost to bulge from the skin of the moon itself. These are the giant lunar domes, and they are nothing like the sharp, conical volcanoes we are familiar with on Earth. Picture a vast, rounded hill, so broad and gently sloping that you might not even notice its full scale while standing on its surface. These domes can stretch for miles across, yet rise only a few hundred feet at their peak, creating a subtle, almost organic swell in the landscape. Their formation remains one of the moon's more serene puzzles. The leading theory suggests they were created by volcanic activity, but not the explosive, ash-spewing kind. Instead, imagine a very thick, viscous lava, something akin to toothpaste, slowly oozing up through a vent in the lunar crust. This dense lava would not flow far, instead piling up around the vent in a large, symmetrical mound before cooling into solid rock. Yet, this explanation does not fully account for their perfect, smooth contours and immense size. Some domes are so large and uniform that they seem more like colossal blisters than simple piles of rock. To truly appreciate their strangeness, one must view them through 3D terrain models that reveal their true profile. When you see a dome next to a typical impact crater or a jagged mountain range, its otherworldly smoothness becomes starkly apparent. It stands apart, a silent, rounded monument to a volcanic process far gentler and more mysterious than anything we know. Even the vast lunar plains are scarred by channels that look eerily familiar. These are the lunar rilles, and the most perplexing of them are the sinuous rilles. They snake across the landscape for hundreds of miles, twisting and turning like the dry, ancient riverbeds of a long-lost world. This presents an immediate and profound mystery, because liquid water cannot exist on the lunar surface. It would instantly boil away in the vacuum of space and be broken apart by solar radiation. So what force carved these meandering canyons into the rock? The most accepted explanation takes us back to the moon's volcanic past. Picture not water, but rivers of fire. The theory suggests that these channels were formed by incredibly hot, runny lava. This molten rock would have flowed with such ease that it behaved almost like a liquid, carving its own path across the terrain. In some cases, the lava might have flowed through underground tunnels, called lava tubes. When the eruption ended and the lava drained away, the roof of these massive tubes could have collapsed, leaving behind the long, winding trench we see today. Yet, this elegant solution does not answer every question. Some of these rilles begin in areas with no obvious volcanic source, like a river with no headwaters. Others have features that do not perfectly match the collapsed tube model, leaving room for alternative ideas. Could some have been carved by incredibly powerful gaseous eruptions, or by a type of volcanic activity we have not yet witnessed? The sinuous rilles are more than just dry grooves. They are a permanent record of a time when the moon was a world of flowing rock, and their full story is still being deciphered from the dust. Beneath the serene plains and winding rilles lies a hidden force that actively tugs at our spacecraft. These are the mass concentrations, or mascons, vast regions of incredibly dense material buried deep under the lunar maria. Their discovery was not made by camera or telescope, but through the wobbling paths of early lunar orbiters. Mission planners found their careful calculations thrown into chaos, as spacecraft would mysteriously gain speed or dip in their orbits when passing over the great dark basins. It was as if the moon itself possessed hidden anchors of immense weight, warping the local gravity in ways no one had predicted. The leading theory points to a violent origin in the moon's distant past. When a colossal asteroid slammed into the moon, the unimaginable force of the impact excavated a gigantic crater and sent ripples of molten rock surging upward from the mantle below. This dense material, along with the remains of the asteroid itself, then settled into the basin, creating a permanent, concentrated lump of extra mass hidden just beneath the surface. It is a fossil of that ancient cataclysm, forever pulling at anything that passes overhead. Yet, this explanation is not the final word. The precise makeup of these dense pockets remains uncertain. Are they pure iron from the asteroid core, or a unique mix of heavy elements from the lunar interior? Even more puzzling is the full shape of their gravitational influence, which is far more complex than a simple, heavy ball. These mascons create a bumpy, unpredictable gravity field that makes precise orbital maneuvers a constant challenge. How can something we cannot see exert such precise and powerful control over the very motion of our probes? This invisible landscape of gravity hints at a lunar interior far more complex and layered than its calm exterior suggests. Even the invisible envelope of space around the moon holds its own strange secrets. Scientists were stunned when their instruments detected a fleeting, ghost-like layer of charged particles, a temporary ionosphere, clinging to certain areas of the lunar surface. This discovery was profoundly puzzling because our moon lacks a global magnetic field, the very thing our own Earth uses to trap and hold such particles in a stable, permanent layer. This was not a global feature, but a localized and transient shroud of electricity that appeared and vanished without warning. Spacecraft measured this phenomenon directly, their sensors picking up the faint but distinct buzz of ions where none should logically exist. One compelling theory suggests this could be the work of outgassing. Radioactive elements like radon, decaying deep within the moon's interior, might occasionally push their way to the surface, releasing a temporary cloud of gas. As this gas escapes into the vacuum, the harsh radiation from the sun could strip electrons from its atoms, ionizing it and creating the brief, detectable layer. Another idea points to the solar wind itself, that constant stream of charged particles flowing from the sun. Perhaps when this wind slams into pockets of the moon's own weak, localized magnetic fields, or strikes certain types of surface rock, it gets disturbed in a way that mimics a temporary miniature ionosphere. Yet, neither theory perfectly fits the observations. The events are too sporadic, and the detected particle densities do not always match what the models predict. How can a world without a magnetic heart spontaneously generate its own electrical aura? This mystery reminds us that the moon's influence extends beyond its rocky surface, reaching into the very space that surrounds it, and we are only just beginning to understand the rules of its invisible dance. Among the brief flashes and glows, one particular phenomenon stands apart for its slow, almost deliberate motion. For over 300 years, observers have occasionally reported a faint, nebulous wave drifting across the moon's face. It does not flash or sparkle like a meteor impact, but moves with a steady, gliding pace, a gentle haze that slowly obscures the craters and mountains beneath it before fading away. One of the most famous historical accounts comes from the 18th century, when the astronomer Sir William Herschel, the man who discovered the planet Uranus, witnessed what he described as a slow-moving cloud formation. In more recent times, dedicated amateur astronomers with modern equipment have captured similar events. A faint grayish wave that can take minutes to cross from one side of the lunar disk to the other. This is not a trick of the light, but a consistent, repeatable observation from multiple, independent witnesses. So what could this lunar wave possibly be? The most grounded explanation points back to our own planet. Earth's atmosphere is a turbulent, shifting sea of air, and sometimes subtle layers of differing density can act like a weak lens. This could, in theory, create a moving, wave-like distortion in the image of the moon, a mirage effect that makes the surface itself appear to ripple. Another possibility is an instrument artifact, perhaps a faint smear on a camera lens or eyepiece that, when combined with the Earth's rotation tracking the moon, creates the illusion of a moving feature. Yet, many experienced observers argue against these simple answers. They note that the wave has been seen moving against the direction of the Earth's atmospheric drift, and it has been reported by people using multiple telescopes, ruling out a single dirty lens. This leads to the most tantalizing possibility that we are seeing a genuine, albeit extremely tenuous, lunar atmospheric event. While the moon has no true atmosphere, it does possess an incredibly thin layer of gases called an exosphere. Could there be moments when dust or gas, stirred up by a moonquake or released from a deep vent, gathers into a temporary visible cloud, moving slowly in the weak lunar gravity before dissipating into the void? The lunar wave remains one of the most elusive and controversial of all transient phenomena, a ghostly ripple on a silent sea, challenging us to determine if we are seeing an illusion from our world or a whisper from another. These ghostly magnetic fields offer a puzzle locked deep within the moon's rock. Our own Earth generates a powerful, planet-wide magnetic field from its churning molten core, a dynamic shield that protects us. The moon, by contrast, has no such global dynamo today, its core likely cooled and still. Yet in scattered regions, the lunar rock itself is magnetized, creating localized pockets of surprisingly strong magnetic force. These are not active fields being generated now, but frozen relics, remain at magnetizations preserved in the stone like a memory. The leading theory suggests that long ago, the moon did have a molten, churning core that produced its own global magnetic field, perhaps even stronger than Earth's is now. As volcanic lava welled up onto the surface and cooled, iron-rich minerals within it would have aligned with that ancient planetary field, locking its direction and strength into the rock as they solidified. Then, for reasons unknown, the moon's dynamo shut down, and the global field vanished, leaving behind only these magnetized patches as silent witnesses to a more active youth. But this story is far from complete. The great mystery is not just how these magnetic fossils were made, but how they have survived with such strength for billions of years. What specific conditions allowed these pockets to remain so potent while the rest of the moon lost its magnetism? This is where the puzzle connects back to the beautiful, enigmatic lunar swirls like Rilles Gamma. Many of these bright, swirling patterns align perfectly with these localized magnetic anomalies. It seems the magnetic field, frozen in the rock below, is actively deflecting the relentless solar wind, a stream of charged particles that constantly darkens the lunar soil over time. The protected areas under these magnetic umbrellas stay bright and reflective, painting those ghostly patterns we see from orbit. So the swirls are not the cause, but the spectacular effect. Yet this only deepens the core mystery. What created these specific, powerful pockets of magnetism in the first place? Could massive asteroid impacts have somehow amplified the ancient field in certain locations? Or did unique mineral concentrations form natural magnetic batteries within the crust? The moon's localized magnetism is a two-part enigma, a question of ancient origins and enduring preservation, proving that some of the most profound forces on our closest neighbor are the ones we cannot even see. While we cannot feel its heat from Earth, the moon's surface hides pockets of unexpected warmth. These are the lunar hotspots, small regions that glow brightly in the infrared spectrum, revealing temperatures significantly higher than their surroundings. They were first detected by instruments designed to map the moon's thermal signature, and their discovery was a genuine surprise. The logical assumption would be that these warm areas are fresh impact sites, where a recent meteoroid strike has exposed darker, heat-absorbing material from beneath the surface dust. Yet, many of these hotspots show no such correlation. They exist in geologically quiet plains, far from any obvious signs of recent violent activity. So what is generating this mysterious heat in the middle of the moon's frigid, airless landscape? One compelling theory suggests we are witnessing the last, faint whispers of the moon's volcanic past. The idea is that deep below the surface, in isolated pockets, radioactive elements like uranium and thorium are still decaying. This process generates a small but steady amount of heat, which could slowly conduct upwards through the rock, creating a localized warm spot on the surface. It would be a dying ember of the moon's once fiery interior. Another possibility points to the physical properties of the lunar soil itself. Perhaps in these specific areas, the soil, or regolith, is composed of grains that are rougher or darker, allowing them to absorb solar energy far more efficiently than the lighter, more reflective soil around them. They would act like tiny, natural solar panels, soaking up the sun's rays and holding onto that heat long after the surrounding areas have plunged in the deep cold of the lunar night. Then there is the more dramatic prospect of residual volcanic activity. Could there still be small, isolated magma chambers, not large enough for a full-scale eruption, but still warm enough to slightly raise the temperature of the rock above them? This would imply that the moon is not entirely geologically dead, but merely sleeping, with a faint pulse of warmth still detectable if you know where to look. Each hotspot is a thermal fingerprint, a clue pointing to processes we still do not fully understand happening right beneath our feet. They remind us that the moon's calm exterior may hide a more dynamic and warmer interior than we ever imagined. Just as we detect lingering warmth, another vital resource on the moon plays a frustrating game of hide and seek. The signal for water is one of the most confusing and contradictory puzzles in modern lunar science. For decades, we believed the moon was a completely dry, barren world. Then, advanced instruments on orbiting spacecraft began picking up a clear signature, a telltale chemical fingerprint that screamed the presence of water molecules. The strongest signals come from the coldest places imaginable, the permanently shadowed craters at the lunar poles. These are deep, dark pits where sunlight has not reached for billions of years, cosmic freezers that could perfectly preserve water ice delivered by comets. The data seemed conclusive, a breakthrough that promised to revolutionize space exploration. Yet, when other probes, equipped with different types of sensors, looked at these very same craters, they saw a much weaker signal. One instrument might shout the presence of a significant amount of ice, while another, peering into the same eternal darkness, only whispers. This has sparked an intense and ongoing debate among planetary scientists. What is the true form of this water? Is it a relatively pure, sheet-like layer of frost? Or is it just a few precious water molecules chemically bound to individual grains of lunar dust? A substance so sparse you would need to process a dump truck of soil to get a single glass of water. The distribution is just as mysterious. Is the water ice concentrated in rich, minimal patches? Or is it scattered in a thin, frustratingly diffuse layer across the vast polar regions? This is not merely an academic argument. The presence, abundance, and accessibility of lunar water is the single most critical factor for the future of human presence beyond Earth. Water is not just for drinking. It can be split into hydrogen and oxygen, the very components of rocket fuel. A lunar base with a reliable water source effectively becomes a cosmic gas station, a stepping stone to the rest of the solar system. So the question of whether the water signal is strong or weak, pure or polluted, is the difference between a sustainable future in space and a prohibitively expensive one. The disappearing water signal is a high-stakes detective story, where the clues keep changing and the ultimate prize is the key to unlocking the stars themselves. The moon is not a silent world. For 8 years, the sensitive seismometers left by the Apollo astronauts listened to its hidden vibrations, recording thousands of subtle tremors we call moonquakes. Most of these were deep moonquakes, occurring some 700 kilometers below the surface, and their rhythmic timing points to a clear culprit, the gravitational tug of the Earth, flexing the moon's rigid interior like a slow cosmic tide. But other quakes defied such easy explanation. The network detected rare, shallow moonquakes, originating only tens of kilometers down, and these were a different beast entirely. They were far more powerful than their deep counterparts, with some releasing as much energy as a magnitude 5 earthquake, enough to seriously damage any future lunar base. And their origins remain profoundly mysterious. They do not correlate with the Earth's tidal pull, and they do not match the timing or location of recorded meteoroid impacts. They seem to be generated by something happening within the moon itself. So what could be shaking the moon from the inside out? One possibility is that the lunar crust is still experiencing tectonic activity. As the moon slowly cools and contracts, its crust wrinkles and cracks, much like the skin of a drying apple. These global contractions could build up stress along ancient fault lines until the rock suddenly slips, releasing a burst of seismic energy. Yet, the locations of these shallow quakes do not always align perfectly with the known fault scarps we have mapped. This leads to an even more intriguing idea, that we are seeing the effects of a partially molten interior. Perhaps there are still pockets of hot magma deep within the moon, and as they shift and settle, they trigger tremors in the crust above. The data suggests a world that is not entirely geologically dead, but one that occasionally groans and shifts in its sleep. These unexplained tremors are a stark reminder that we have only just begun to listen to the moon's hidden heartbeat, and what we are hearing challenges our very understanding of a quiet, unchanging neighbor. Scattered across the moon are lines of craters that run in unnervingly straight formations. These are the crater chains, and one of the most famous is the Davy chain, a near-perfect line of about 24 pits marching in lockstep across the landscape. At first glance, they look like they were made by a single object that skipped across the surface, like a stone skimming a pond. But the physics of a single, solid asteroid impact do not support this. A large impactor would shatter on first contact, and the resulting secondary craters from ejected debris are almost always clustered and chaotic, not arranged in a perfect sequential line. So what kind of cosmic event could create such a precise linear pattern? The leading theory is as dramatic as it is elegant. It points to a comet that ventured too close to the moon. As a comet approaches a massive body, the difference in gravitational pull between the side closest to the planet and the side farthest away can become overwhelming. This tidal force can stretch the comet's fragile, icy nucleus until it pulls apart, breaking it into a string of smaller fragments, much like a string of pearls. This procession of comet pieces, still traveling at immense speed along the same trajectory, would then slam into the surface one after another, each impact creating a crater and together forming that perfect, devastating chain. Yet, this compelling idea is not without its own mysteries. The precise mechanics of how a comet tidally disrupts, and the exact number and size of the fragments it produces, are still hotly debated. Some crater chains appear so perfectly coordinated and linear that they seem to demand an almost impossibly precise breakup of the original body. Could there be other forces at play, perhaps involving swarms of objects that were already gravitationally bound before they ever reached the moon? The existence of these strange chains forces us to look up from the lunar surface and consider the violent, unraveling dances that occur in the space around us, leaving their perfect scars as a permanent record. These pits are more than just holes, they are gateways. Dotting the lunar surface are profound voids known as pit caves, deep shafts that plunge into an eternal darkness. Many are believed to be skylights, places where the roof of a massive subsurface lava tube has collapsed, revealing a cavernous emptiness below. The sheer scale is staggering, with some pits wide enough to swallow an entire city block. But their true anomaly is not just their depth, but their climate. While the lunar surface bakes at over 270 degrees Fahrenheit during the day and plummets to 250 degrees below zero at night, the temperature at the bottom of these pits remains remarkably stable. Data from orbit reveals a constant shirt-sleeve environment of around 60 degrees Fahrenheit, a perpetual, gentle coolness shielded from the brutal extremes just meters above. This stable temperature hints at a sealed, protected world, a potential underground sanctuary from cosmic radiation, solar flares, and the endless barrage of micrometeorites. For future explorers, these pits represent the most promising real estate on the entire moon, natural pre-built structures for a permanent habitat. Yet, the profound mystery is what actually lies in that permanent shadow at the bottom. Our orbital cameras can only peer so far into the abyss. Is the floor a jumble of collapsed rock and ancient lava flows? Or could it be a treasure trove of volatiles? Water ice, frozen for eons, could have accumulated in these cold traps, preserved just out of the sun's reach. Other exotic compounds might also lie dormant, chemicals that have not seen the light of day for billions of years. These pits are not merely geological curiosities. They are time capsules and potential oases, holding secrets about the moon's volcanic past and the raw materials for our future, all waiting in the cool, silent dark. Even the rocks on the moon are not content to sit still. Scattered across the dusty plains, you can find their lonely trails, the unmistakable tracks of massive boulders that have rolled, slid, or bounced for incredible distances before coming to a halt. These are not subtle marks, but deep, clear grooves carved into the regolith, some tracing paths for miles across crater walls and down into the valleys. The mystery is not that they moved, but what powerful hand shoved them in the first place. On Earth, a boulder might be set in motion by a rainstorm loosening the soil, or a river undercutting a cliff, or even just the persistent push of the wind. But the moon is a vacuum, a world without weather, without water, and without any obvious force to start these multi-ton stones on their epic journeys. So what colossal event provided the initial push? The most logical suspect is a moonquake, a powerful shallow tremor like the unexplained ones the Apollo seismometers detected, could have shaken the ground like a giant drum, destabilizing slopes and sending precariously perched boulders on their way. Another clear candidate is a meteoroid impact. The shock wave from a strike, even one many miles away, could ripple through the ground, vibrating the surface enough to dislodge rocks and set them rolling. Yet, for some of the longest and most dramatic trails, these explanations begin to strain. The energy required to start a house-sized boulder moving is one thing, but to keep it traveling in a straight line for over a mile, navigating subtle changes in terrain, seems to demand a more sustained or peculiar force. This is where a more subtle, daily phenomenon comes into play: thermal fracturing. The lunar surface is a place of extreme temperature swings. Over the 2-week-long lunar day, a rock bakes in the relentless sun, its surface expanding. Then, during the equally long night, it contracts in the deep cold. This endless cycle of expansion and contraction can, over thousands of years, cause the rock to crack and shift its position on a slope. A tiny, almost imperceptible nudge from this thermal stress, repeated cycle after cycle, could eventually be enough to overcome friction and send the boulder on its slow, patient journey downhill. But even this elegant theory cannot account for every single track. Some boulders appear to have moved uphill or made sharp 90-degree turns in their paths, maneuvers that defy simple gravity and momentum. The trails they leave behind are silent testimony to events we can only reconstruct from the marks in the dust, a permanent record of a moment of motion on a world we so often think of as perfectly still. The moon occasionally exhales. These are not the slow, drifting waves reported by observers, but sudden, localized puffs of gas, seen as transient, hazy clouds that appear and vanish in minutes. Telescopes have captured these events for decades, and modern orbiters have added their own data, detecting the faint chemical signatures of these brief exhalations. The leading suspect is a gas called radon. a product of the natural radioactive decay of elements like uranium and thorium deep within the lunar interior. As these elements break down over billions of years, they release energy and generate gases that must eventually find a path to the surface. The theory suggests that these radon seeps are the lunar equivalent of a geothermal vent, a slow, steady leak from a radioactive underworld. Yet the behavior of these gaseous ejecta is strangely inconsistent. They do not always emerge from the most volcanically active-looking regions, and their timing seems random, not linked to any external trigger like a meteor impact or a moonquake. Even the composition of the gas can be a puzzle. While radon is a prime candidate, some detections hint at other, lighter gases being present, which would suggest a different, more complex source. If it were simply a matter of steady radioactive decay, we would expect a more predictable, widespread pattern of release. The fact that it is so localized and sporadic implies that the moon's subsurface plumbing is far more intricate than a simple, porous sponge. There may be sealed pockets of gas, trapped under layers of impermeable rock, that only release their contents when a deep moonquake or a subtle shift in the crust creates a new fracture for them to escape. These brief clouds are more than just gas. They are messages from the dark, telling us that the moon's interior is not a still and silent place, but one with pockets of pressure still seeking a way out. The very crust of the moon is a planetary mystery in itself. It is made almost entirely of one specific type of rock, a bright, crystalline material known as anorthosite. This is not a local curiosity. It forms a global shell, the primary bedrock of the entire lunar surface, and its purity is startling. On Earth, anorthosite is a rare geological treasure, found only in a few ancient mountain ranges. But on the moon, it is the default, the foundational stone from which the highlands are carved. This strange uniformity points to a cataclysmic beginning, an event so violent it reset the entire world. The leading theory describes a lunar magma ocean. Picture the infant moon just after its formation, completely molten from its surface to a great depth. This was a global ball of liquid rock, swirling with different minerals. In this seething chaos, the heavier, darker minerals like iron-rich olivine and pyroxene began to sink. They settled downward like dregs settling in a cosmic cup. Meanwhile, the lighter crystals, the plagioclase feldspars that form anorthosite, floated. They accumulated at the top, forming a thick, floating crust of bright, buoyant rock as the ocean slowly solidified over millions of years. It is a beautifully elegant story, but modern simulations reveal a profound problem. The process, as we model it, should not have created such a pure and widespread layer. The sinking and floating should have been messy, with different minerals getting trapped and mixed together. Our computer models struggle to produce a global crust of nearly pure anorthosite without invoking special, unknown conditions. What was different about the moon's early environment that allowed this perfect separation to occur? Was its magma ocean deeper or hotter than we assume? Did it cool at a very specific, slower rate that allowed the crystals to separate with impossible efficiency? This is not just a question about rock formation. The anorthosite enigma strikes at the heart of the moon's own origin story. The leading theory says the moon was born from the debris of a giant impact between the early Earth and a Mars-sized object. The properties of this lunar magma ocean and its ability to form this unique crust are a direct test of that violent birth. If we cannot explain how this pure, global crust came to be, it challenges our fundamental understanding of how the moon itself was created and cooled. The bright highlands we see every night are not just landscape. They are the enduring, unresolved question of the moon's first moments. This stark division is written across the face of the moon itself. Lift your gaze from the familiar dark seas of the near side, and you would find a completely different world on the far side. It is a landscape of relentless brightness, a battered, thick crust of highlands crowded with craters upon craters. There are no vast, smooth maria to break the chaos. This is the great lunar dichotomy, and its origin is one of the most fundamental mysteries about our celestial partner. Why does the moon have two faces? The most prominent theory points to a colossal catastrophe early in its history. The idea is that the near side was struck by a gigantic asteroid, an impact so violent it cracked the crust to its core and created a titanic basin, the procellarum region. This catastrophic wound would have thinned the crust dramatically, creating a weak point. Later, when the moon's interior was still hot and volcanically active, vast floods of dark, runny basalt lava found it easier to well up through this fractured, thinner crust on the near side. They spilled out, filling the giant basins and creating the dark plains we see as the man and the moon. The far side, protected from that single, shattering blow, retained its thick, primordial crust, its ancient highlands too robust for the lava to penetrate in such volume. Yet, this elegant story is now being questioned. Why would such a massive impact only strike one side? New data from gravity mapping orbiters suggests the procellarum region is not a traditional impact basin at all, but a vast scar from a different process, a massive plume of hot material rising from the deep interior. This suggests the asymmetry might be an inside job. Perhaps the moon's radioactive elements were concentrated unevenly during its formation, making the near-side mantle hotter and more prone to volcanic flooding. Or maybe the early Earth's immense gravitational pull, when the moon was much closer, literally tugged and stretched the near-side crust, making it thinner and priming it for its volcanic destiny. The two-faced nature of the moon is not just a surface feature. It is a clue to the violent internal and external forces that shaped it from the very beginning, a planetary puzzle where the answer lies buried deep beneath both the dark seas and the bright, hidden highlands. Sometimes, the moon loses things. In 1970, the Soviet Union successfully landed the Lunokhod 1 rover, a remarkable robotic vehicle that trundled across the dusty plains. Its mission included a crucial scientific instrument, a laser reflector, a sophisticated array of mirrors designed to bounce laser beams sent from Earth directly back to our observatories. By precisely timing the light's round trip, scientists could measure the Earth-Moon distance with incredible accuracy, tracking the moon's gradual drift away from our planet. But after its mission ended, the rover and its precious reflector fell silent, its exact location lost in the vast lunar expanse for nearly 4 decades. Then, in 2010, something extraordinary happened. Scientists analyzing images from a NASA orbiter managed to pinpoint the long-lost rover. Out of curiosity, they aimed a powerful laser from an observatory on Earth at the calculated coordinates. To their absolute astonishment, they got a signal back, a brilliant and clear reflection far stronger than anyone had predicted. This was not just a faint echo. The Lunokhod 1 reflector was now performing better than its newer, functional counterparts on the moon. How could this be? The rover had been sitting idle in the harsh lunar environment for 40 years, exposed to relentless cosmic radiation and temperature extremes that should have degraded its mirrors, not improved them. One theory suggests that during its long dormancy, the rover might have settled or been jostled by a tiny moonquake into a perfect orientation. Perhaps its reflector panels, originally at a slight angle, were knocked to face Earth more directly, optimizing their ability to bounce light back to us. But the sheer intensity of the return signal has led to another, more intriguing possibility. Maybe a layer of highly reflective lunar dust settled on the rover's mirrors. This sounds counterintuitive, as dust should obscure the surface. Yet, the fine regolith on the moon is not like Earth's dirt. Its particles are jagged and glassy, the result of eons of meteoroid impacts that melted and shattered the rock. If a specific type of this dust, with just the right reflective properties, coated the reflector at a perfect angle, it could have accidentally turned the entire rover into a giant, diffuse mirror, scattering light back with unexpected efficiency. This small, persistent enigma reminds us that even our most carefully placed instruments can become part of the moon's mystery. Their stories were written by the very environment they were sent to study. Another claim pushes the boundaries of what we think is possible on the lunar surface. Some researchers and enthusiasts point to photographs that seem to show a colossal, transparent dome. This structure, they argue, is a vast, glass-like enclosure, something that could only be the work of a sophisticated intelligence, a habitat or observatory built under the alien sky. The images used to support this are often grainy, blown-up sections of official lunar photography, where a certain curved, shimmering line appears to stand out against the gray, dusty backdrop. It looks, for all the world, like a giant bubble half buried in the regolith. This is a powerful image, one that immediately fires the imagination and suggests a hidden lunar civilization. Yet, when we apply the tools of critical analysis, this compelling vision begins to dissolve into a series of more mundane, but no less fascinating, explanations. The primary culprit is often a simple lens flare. When a camera is pointed toward a bright source of light, like the sun glinting off a lunar mountain, internal reflections within the complex glass elements of the lens can create artifacts. These are not real objects in the scene, but phantom shapes and arcs of light projected onto the image by the camera itself. The curved, ethereal line of a proposed dome can be a perfect match for such an internal reflection. Furthermore, the heavy digital processing often applied to these images to bring out detail can accidentally enhance these artifacts. Sharpening filters and contrast adjustments can turn a faint, meaningless smudge into a sharp, defined line that our brains desperately want to interpret as a structure. This is where the powerful human tendency of pareidolia comes into play once more. Our minds are hardwired to find familiar patterns, and a smooth, curved arc is one of the most fundamental. We see the arch of a dome because our brain is determined to find order, even in optical noise. This entire case serves as a vital lesson in how we investigate the unknown. The most extraordinary claims do not just require evidence. They demand that we first rule out all the ordinary, earthly explanations, from the physics of our own cameras to the quirks of our own perception. The true discovery here is not a glass city on the moon, but a deeper understanding of how easily we can project our hopes and fears onto the silent, neutral landscape of another world. Even the invisible rain of deep space behaves strangely on the moon. Cosmic rays, the high-energy atomic fragments that streak across the universe, should fall upon the lunar surface in a steady, uniform shower. With no atmosphere to break them up, the entire moon should be bathed in this constant, predictable radiation. Yet our instruments have told a different story. Some detectors placed on the surface have recorded puzzling fluctuations, unexpected spikes and dips in the intensity of this cosmic downpour. and an overabundance of certain types of particles that the models did not forecast. It is as if the moon itself is selectively sprinkling this radiation, creating invisible hotspots and quiet zones that defy our understanding of physics. One compelling explanation points back to those ghostly, localized magnetic fields frozen in the lunar crust. Just as they protect the soil to create the bright swirls, these magnetic bubbles might also act as miniature shields against cosmic rays. Charged particles, which make up a significant portion of this radiation, could be deflected by these fields, bending their paths away from certain areas and funneling them towards others. This would create a patchwork of radiation on the surface, a hidden landscape of relative safety and unexpected danger. Another theory looks at the ground itself. Perhaps when cosmic rays slam into the lunar soil, they trigger a secondary effect. The impact could shatter atoms in the regolith, creating a spray of new secondary particles that our instruments then detect, creating the illusion of an overabundance. The soil itself would be generating its own unique radiation signature. But here is the core of the anomaly. Neither of these theories perfectly accounts for the data. The measured variations do not always align with the known magnetic maps, and the secondary particle showers do not fully explain the specific types and energies being detected. This indicates a fundamental gap in our models of space, weather, and how planetary bodies, even airless ones, interact with the sea of radiation that fills the void. For future astronauts, this is not an abstract puzzle. It is a matter of survival. Understanding where and why these cosmic ray variations occur could be the difference between finding a safe haven for a lunar base and accidentally building a home in a hidden radiation trap. The moon is teaching us that the rules of deep space are more complex than we imagined, and its silent surface is an unpredictable conductor for the universe's most powerful energies. So many separate mysteries begin to weave together into a single, grander puzzle. Consider the ghostly lunar swirls, those bright patterns painted on the dust. They are not random art, but appear directly over patches of powerful, localized magnetism. These frozen magnetic fields act as invisible shields, deflecting the relentless solar wind and preventing the soil from darkening. This solves the riddle of the swirls, but immediately creates another. What created those intense magnetic pockets in the first place? The answer might lie deep underground, tied to the same seismic forces that cause powerful, shallow moonquakes. A massive moonquake could be the result of a sudden shift in the crust, a shift that also realigns the magnetic minerals locked in the rock below, potentially creating or altering these mysterious magnetic anomalies. And what happens when the moon's interior shifts and groans? It can release trapped gases in sudden, high-pressure bursts. This outgassing could explain the transient lunar phenomena, the brief puffs of cloud and flashes of light that have baffled observers for centuries. A single event, a deep internal tremor, could theoretically trigger a moonquake, amplify a local magnetic field, and force a cloud of radon gas to the surface all at once. This interconnected web suggests a world where internal heat, magnetic fossils, and surface phenomena are all part of one dynamic system. Solving the mystery of the moonquakes could unlock the secret of the magnetic fields, which would finally explain the beautiful swirls, and in turn shed light on the fleeting gas clouds. The moon is not a collection of isolated oddities. It is a single, complex machine, and we are only just beginning to understand how its hidden gears turn in the dark. This deep web of mysteries is precisely why our journey back to the moon is more urgent than ever before. We are no longer just visiting, we are sending detectives to a cosmic crime scene, armed with tools designed to solve these very puzzles. NASA Artemis program, alongside a fleet of international robotic landers, represents a new era of exploration, one targeted directly at the moon's most baffling anomalies. These missions will deploy sophisticated instruments to listen for the deep, unexplained moonquakes, mapping the lunar interior with seismic precision to understand what truly shakes this world. Advanced spectrometers and radar systems will peer into the permanently shadowed craters and down into the gaping pit caves, finally resolving the maddening contradiction of the water signal. They will tell us if those dark voids hold accessible ice, the key to a sustainable human future off-world. Orbiters equipped with incredibly sensitive magnetometers will chart the ghostly magnetic fields in high definition, uncovering the origin of the beautiful swirls. And for the first time, we will have a continuous global surveillance network, a set of electronic eyes constantly watching for those fleeting flashes of light and puffs of gas, ready to catch a transient lunar phenomenon in the act. The next decade will transform the moon from a distant object of mystery into a world we are actively deciphering. Every strange shutter, every hidden resource, every ghostly magnetic patch is now a scientific target. The greatest chapter in the story of lunar anomalies is not in the past, but is being written now, in the quiet halls of mission control and the silent vacuum of space, as we prepare to return and finally ask the moon our questions face to face. From glowing patterns to invisible forces, these 25 mysteries reveal a world stranger than we ever dreamed. We have wandered through the ghostly artistry of the lunar swirls and witnessed the fleeting fireworks of transient lunar phenomena. We have scaled the impossible heights of the shard and the tower and descended into the stable, sheltered darkness of the pit caves. We have felt the pull of hidden mascons, listened to the deep groans of moonquakes, and puzzled over the pure, global crust of anorthosite. We have seen rocks that wander on their own, felt the warmth of hidden hotspots, and chased the contradictory signal of water. We have encountered the moon's two-faced nature, its localized magnetic ghosts, and its sporadic gaseous breath. Each anomaly, from the precise lines of crater chains to the baffling strength of a lost laser reflector, stands as a testament to a fundamental truth. Our closest celestial neighbor is not a simple, dead rock. It is a complex world with a dynamic past and a present that is still active in ways we are only beginning to perceive. The greatest secret the moon holds is the sheer depth of what we have yet to learn. This enduring mystery is what calls us back, fueling the rockets and the rovers of a new age of discovery. It is the same human drive that has always pushed us to look up at that bright disk in the sky and not just see a face, but see a frontier. The story is far from over. The next chapter is being written now, and you are here to witness it. So tell us, which of these lunar mysteries captured your imagination the most? Was it the idea of hidden caverns perfect for a future base, or the beautiful, unexplained swirls that look like celestial graffiti? Let us know your thoughts in the comments below. And if you want to continue this journey of cosmic discovery with us, be sure to subscribe. The universe is full of wonders, and we have only just begun to explore